Fodor, back in 1975, in The Language of Thought, was writing about reductionism and the possibility of reductionism. And he suggested that it wasn't possible, and even if it was, it wasn't worth it. So you might have some special science where you talk about things at a macro level, memories, thoughts, presences, desires, hopes, okay? Or, you know, your inferred referential intent of some speaker. And so you might have lawful relations, you know, some judgment of a speaker's gaze direction, their inferred referential intent, and you can talk about those at a macro level. But then what happened when you went down inside to the neuroscience level or to the P level, which would be physics in this example? Each one of these events would be related to a myriad of other things. There would be no natural kinds that mapped in any reasonable, coherent, or informative way, okay, to the upper level. Okay. And Fodor is pretty much right, I think, in this analysis, but I think he's wrong in what you take from it. So, and what he took from it was we could all just live up there. Those of us who cared about phenomena at this macro level, we could just do that. And who needs the brain? Who needs physics, right? Well, you know, scientists are not like that, okay? Scientists want unity. And they want to bridge between levels. And actually, you want scientists to do that. You do not want your oncologist to have theoretical pre-commitments about levels of analysis, right? You don't want that, okay? No. But unity, the point I want to make here is unity does not mean reduction, okay? So this is actually a levels of analysis across multiple levels, from, you know, the epigenesis of folding proteins on down to getting what are called crawling cells. These are cells with motility that can actually move in your system. So that's like a whole entity there. And what you want to do is you want to understand how all these levels come together, and you want to understand the complex system that is the context of it all coming together. The other thing is reductionism doesn't mean determinism, okay? These are literally events in time. They are very, very, very complex. They can go lots of different ways. If life goes right for you, they go the right way most of the time, if you're talking about your bodily cells, okay? But they don't all go the same way. All right, so science wants unity. So if science wants unity, what do we do about Fodor's point? This is the larger issue behind this talk. And the approach that I'm taking to thinking about it is one that was suggested by Ballard and Hayhoe in 1997 in a highly influential behavioral and brain sciences paper. And they suggested that between the cognitive level, which you can think of events happening in time at the 2 to 3 second mark, this would be like deciding to reach for something, to, you know, call somebody on the phone, figuring out which object is the intended referent of some speaker. And between the more internal levels, happening on fractions of seconds and single milliseconds when you get low enough, that there was a critical level which they called the embodiment level. And what was important about the embodiment level, it was that it would allow us to link from the outer behavioral, the sort of pop psychological terms in which we all, or folk psychological terms in which we all talk about things, it would give us the linking function to down under. Okay? So that's what I'm trying to do. And I'm going to think about these macro and micro levels in the context of children's learning the reference of words. So words refer, well, in the formal sense that they're about things, but as developmental psychologists often talk about them, or as computer scientists talk about it, by pointing. They serve as indexes, pointing to something, either computationally or, for a young child, maybe actually really. Okay? So they direct attention and thought, which is missing its T, to a thing in the world, to a memory, and to an idea. Now the problem for developmental theorists, or for theorists of word acquisition, is if you know no words, how do you figure out what any word refers to? You're going to have to do it by the co-occurrence of the word to a scene. But that is fraught with problems. So this is actually considered one of the core theoretical problems in early word learning. It's what everybody worries about. And it's the fact that in a visually cluttered world with many possible reference, like in that cluttered scene, the garbage on the floor, the bottles on the table, the paintings on the wall, if someone says something, how can you possibly figure out what they're referring to if you as yet know no words, if you're the infant learning? You can even give constraints, like it's only going to be to visually segmented objects, so forth, and it is still a very hard problem. Okay? And that's known as a problem of referential disambiguation. Now, the data and theory that are out there suggest several kinds of solutions. They suggest that children are able to infer speakers' intent from eye gaze and gesture. They suggest that children use linguistic cues and known words to constrain their inferences about the likely referent of some word that somebody utters, and that children are endowed with assumptions and biases about how words map to reference. And this is how they solve this referential disambiguation problem. Okay. And I said data and theory, and you should know there's lots of data to support these claims. Okay? Lots of experiments, lots of demonstrations. Okay? But what I want you to also know is that these are all explanations at a macro level. Really, they use pop, folk psychological terms that have no, except maybe to philosophers, any stuff under them, okay? I mean, intent. What's intent? Okay. These high-level, macro-level terms. Okay. What I want to do today is tell you about some attempts to go underneath it, to actually take that Ballard embodiment level and get a different view. Go down micro. So this, as I said, is the view that cognitive theorists have in mind. But of course, it's only the right view if children stand back and learn words, you know, by looking at the world as if they're watching a screen. And we have to, but the view, of course, that matters to children isn't what philosophers or cognitive scientists think is their view of the world. It matters what their view of the world really is. So the first question we want to ask is, what is that view? And the thing to remember is that the child's view of the world is inherently linked to the body. Every eye gaze shift, every head turn, every fall, every move, okay? Every bodily move changes what's in view. So here's the basic structure of the talk. I'm going to tell you that young children have very different views than we do. And that I'm going to ask what their particular view is good for. And then I'm going to turn to the issue of joint attention, somewhat briefly. But this is how people normally think the problem is solved. And I'm going to tell you some new things about that from the underbelly side. And then I'm going to come back to Fodor's problem and the relation between the macro and micro, and what we might want to do about linking functions when the links aren't so straightforward or transparent. All right, and I need to say right up front that everything I'm talking about here is done in collaboration with my colleague Chen Yu. All right, so I'm going to tell you a bunch of experiments, and I took virtually every graph out of here, okay, guys, so you can sit back. I have one, though, that's a killer graph, and so I had to leave it in. All right, so in all these experiments, what we do is we have parents and children playing with objects on the table. And you might say, why are we doing tabletop play? Well, this is a common activity of mother and children. It's a common activity in which children learn about objects, and a common activity in which they learn object names. And for those of you who aren't developmentalists, it is, or think really about how vision really works in real time with moving bodies, it is known to be very challenging to the visual attentional skills of children, hard for them to sustain attention on a single object, to not sort of get pulled off. Okay. It's actually used if you had a child who had a developmental disorders, they'll use object play on the table as a measurement of their, if you're talking toddlers, as a measurement of their attentional development. what we do is we take dense multimodal measures. We have motion sensors on the hands, motion sensors on the heads, have a head camera on the head, and in the newer experiments we actually are doing, and I'll tell you that at the end of the talk, dual eye tracking of mothers and children as they interact, okay? I'm mostly going to be talking about the visual system. There's lots and lots of interesting things to say about the hands and heads and the actual velocities and trajectories in the course of all this, but I'm going to leave that aside for clarity and brevity. And instead I'm going to be talking a lot about our data from the head camera and from head-mounted eye tracking. Now the head camera, of course, is a head-centered view of the world. So if my head is moving this way, the camera moves that way. But of course my eyes and head don't have to move together, and so you could worry about whether there are in alignment. You won't be worried by the end of the talk. But I'm going to tell you that you don't need to be worried ahead. Young children hardly ever hold the eyes and head out of alignment, not when they're physically active. Babies do when they don't move, when they're sitting in their pumpkin seat. That's an interesting idea for later. But toddlers who are moving and beginning to move, they want to keep them aligned. And so this is just a child's, this is the head camera image. This is from an eye tracking study, and every one of these white dots is a fixation. They're really mostly in the center. So the point you just need to take from it is it's a good, not perfect, but a good approximation of what's in view. All right, so in one of the first experiments, well, second experiment we did on this, we collected 6 minutes of play from each dyad. We have 3 cameras, 2 head cameras, an overhead camera. We're recording at 10 frames a second. You need to think about this. It is a lot of data. So the other thing you need to know is we do automatic image analysis. So I'm going to be, all our data is frame by frame, very rapid rate, high density, real-time data. And basically what our image analysis is able to give us is the objects that are in any individual's view, the size of the objects in that view. Size depends if all your objects are roughly equal size, which they are in these experiments. Size depends on how close the object is to you and whether you have something occluding it, okay? So it's a momentary visual property of the object. We'll talk about some other properties as well. All right, but before we do any data, you need to see this. This is a head camera on a child. This is a head camera on the mom as they're interacting. And they're supposed to play together. The cameras are identical. There is no cropping, no altering. These are identical cameras on the two participants. We developmental psychologists can't help ourselves. We always go for the laugh here. Okay. All right, here's just another one. This is a child with a father, slightly different set of toys. So you get So this is just to make, to say what I just said to you before. Most of the data I'm going to talk about is what's in view, and I'm going to talk a lot about image size. Okay, and I'm going to talk about which image size on any given frame is determined by the proximity of the object and its occlusion. And just so you know, this blue thing is 37% of the head camera image. This pepper is 23% of the head camera image. This pepper is 14% of that head camera image. Anything above 10% of the image is huge visually. Okay? All right. All right, 2 graphs, sorry. All right, actually, there's another one coming up. It's a kilograph. I forgot about this one. Okay, but this just makes the point. This is just one child and its mother in real time. This is the proportion of the blue object in the head camera image, the proportion of the pink object in the head camera image, the proportion of the green object in the head camera image. Yellow is the proportion of all hands and faces lumped together, okay? We don't know whose hands and face it is, just the amount of body parts. This here is the mom, okay? So this is frame by frame, what objects are in view and their relative size in the mom's image. Okay? And it's a very stable image. The view is from very far away. All the objects are continually in view. That's because the mother's changing her attention by recentering her eye gaze, not by moving her head. Okay? All those objects they're all in view, within peripheral vision, all in view, and very little change. You could actually record the mother's view by sticking a camera on a tripod with no one moving it, okay? Because that's what you would get. This is the child's view. It's a very different view with a very different dynamic structure. Objects come rapidly in and out of view. Often there is only one object in view, and it's huge, 80% of the image. Okay. Very different dynamic structure. The child's is close, dynamic, often one view. The parent's is far with a constant composition. Now, just so you don't worry about it, so these are just samples here of children's views, parent views, overhead views, to get a good look at what's happening. These are not an artifact of the geometry of the play situation, and they are not an artifact of the head camera. And the easiest way I can show you that is from pictures from our very first head camera study. We had a slightly different setup, but here's a mother and child playing, and there are bunches of objects on the table, okay? And it is the case that the child sat back and watched, they would have a view like this. And you occasionally see views like this that are far and back and like the parent. They're just not very frequent. Most of your views look like that, okay? Where they're holding an object or have their head moved close to an object. And there's one object in view. Now this is really interesting from the point of view of thinking about word learning and reference, because the toddler who's in the midst of word learning, his momentary world doesn't look like this. His momentary world looks like that. There's been a significant reduction in the amount of information and in the visual clutter. Now you can say, why does this happen, okay? It is actually a feature of this organism that they have short arms, and when they are interested in things, they bring them close to their head, okay? That's really, you could view it as a bug, or you could view it as a feature of young children. And today's talk is that it's a feature. All right. Now you might ask, what are the parents doing here? They're like playing, okay? And I don't want to go a whole lot into this. We've done lots of studies of what parents are doing, and they are doing something. So I'm going to, towards the end, tell you a little bit about that. And it certainly is the case that we sometimes see frames that look like this, where the mother's handing over some object and making it big in the view, as well as frames like that. But these account for 20% of all frames in this particular study, and these kind of views where it's in the child's hand counts for 64% of the view. We can also do, okay, another graph, I forgot how many I got here. You can also do a thing by asking what events over time lead up to these points where you have a single object large in the view. And so what I'm going to show you next is what's known as a probability profile, where I'm going to plot for you the probability that the object that ends up, the single object dominating in the child's view, was in the child's hand versus the parent's hand for the 10 seconds prior to it becoming dominant. Okay? And this is the probability that this object was in the child's hand prior to reaching this point of being the only object in view. And this is the probability that it was in the parent's hand for the 10-second period before. Point is, it's about kids holding objects. All right. So here's the idea. The idea is that the self-organizing properties of heads, hands, the physical geometry of toddlers' bodies, and the geometry of the physical world mean that when a toddler is actively and manually engaged with an object and interested in that object, that will effectively bring that object close, and it will reduce visual clutter and competition at the sensory level. And this is another point I sometimes talk about, what we're not doing movements, but during these periods of holding, they also stop moving. Head stabilizes. But we won't go there today. All right. So, what is this good for? I said it was a feature, not a bug, right? So what's this good for? Well, let's find out. So we have now completed 2 studies in which we do the same kind of thing I just told you about. We have children playing with objects on a table with their parent. Only now the objects are all novel, and the parents are taught the names of these objects before the experiment. And we say to the parents, we don't tell them to teach them the names. We say, here, play with these objects with your children, engage them as much as you can, keep them interested. And if you name them, because of our microphones, everybody's suited up, they believe anything we tell them at this point, that we'd like you to use these names. Okay? The parents do not know that the children are going to be tested at their end for whether they learned any of these object names. And that's what we do at the end. Okay, so you play with the objects, we've got the head cameras on, and then we test them at the end, the child, for whether the experimenter does the testing, standard developmental psychology testing procedures, as to whether the child has learned any of those object names during the course of this event. And then what we do is, so let's say I test a child at the end, and the child has learned the object name, which is grizzly. I know you know the meaning of that, but these guys don't, and we have to have proper phonotactics. Okay, so the child is tested at the end, and they know the word grizzly refers to the pink object. We then go back and take every moment the mother named the object, grizzly, and we put it in the pile of learned object names. And we're going to call every one of those naming events successful. And then we take every object name, every naming event that goes with object names child did not learn, and we put those all in the pile of unsuccessful naming events. Now, if you're a bunch of experimental psychologists, somebody be raising their hand at this point and say, but you don't know which naming events were good. That's correct, okay? So kid learned grizzly, mother named grizzly 5 times. I take all 5 of those naming events and I throw them in and say, these are good naming events. But of course, maybe only one of them was good. The point is, that's noise in the system that works against us. So if I find something good in this little stack of data, it's even better. And then what we're going to do is I'm just going to tell you about the visual properties of naming moments. The image size of the named object, how centered it is in the head camera image, and also intensity salience. Intensity salience is like, Alba, it's a momentary event that depends on just where the object is relative to the head camera, the lights above, shadows from other objects, okay? So it's not a property of the object per se, it's a momentary property. All right, this is the kick-ass graph. Okay. All right, so let me walk you through it because it's great, all right? These are the properties, I'm going to walk you through it. You don't have to figure it out until I get there. These are the properties of the naming events that were good naming events. These are the properties of the naming events where kid didn't learn the name, okay? Blue is the named object. Red is the other toys on the table, the potential competitors in the disambiguation problem that you might have thought were what Mom was talking about when she said grizzly. Okay, if you just want a really simple message, blue bigger than red over here, blue overlapping red over here. But what this one is object, so here's the naming event, because this is also important. Here's the naming event. This is 10 seconds before that naming event. This is a long temporal window that we're looking at here. This is 10 seconds after the naming event, okay? For object size, the named object in the child's view, when they learned it, when the mother names it, is much, much larger in the image size than the other potential competitors, and that advantage starts 7 seconds ahead of the naming event, okay? and lasts several seconds after it. When the child doesn't learn the naming event, you know, the kid is looking at the object. The mother's not naming objects when it's not in the child's view, but it's not such a big advantage over the competitors, and it doesn't last after the naming event. This here is overlap with the center. We define a region of interest in the head camera image and say, that's the center. That just means the heads and eyes must probably stabilize. And we ask, is the named object in that center? So
And
this
then
is,
so what's on your foot, just you might hurt your foot.
you think I'm gonna hurt
Well,
myself?
it's just wrapped around your foot.
That could hurt myself, okay. So when you learn the object name, the naming events were more likely, the object name was more likely to be centered, and the competitors were not. More overlap in the view for the unlearned object names. This is intensity salience. This is really light reflectance, okay? And you have an advantage of light reflectance also for the learned object name.
Can I ask how the name was elicited?
They're just playing.
It's just.
You and we're just playing, and I'm saying, you know, oh, let's stack them, do whatever. Could you get the Modi over there, and we'll put it on top of the grizzly? It's just spontaneous naming.
It's just whenever the child utters the
No,
name.
mom.
Only mom.
Yeah, only mom. This
But-
is mom naming, child learns the name when tested.
That's why I'm focusing on the test, the nature of the test.
Oh, the nature of the test? Oh, standard, okay. I take the two visual, mom has nothing to do with testing. Kid's in a totally different room. I take two of the
But you're
objects.
eliciting, not the mom.
Not the mom. Two of the objects very far apart, okay? You have a little microphone that says, you know, you look straight ahead, not the kid. That says, you know, Modi, Modi, Modi. You got a camera on the kid's eyes, and you're tracking whether they look to the object when you
It's a
name it.
question of gaze. That
Yeah, that's, the
determines,
test is actually just looking. It's a
Okay.
standard procedure, used by lots of people. All right, so here's what I want to suggest, okay, is we have this sensory motor system. And its properties create optimal visual moments. Okay? And so this activity of the child creates optimal visual moments for learning when one object is isolated at the sensory level. Okay? And when parents name that object at that moment, kids learn it. And this is the brilliant statement of one of my postdocs, okay, who said, this ain't inference. You can take that wherever you want it to go. Right. Now, I just want to add this as an aside for one reason why I find this really, really interesting. We know that in adults, you can selectively attend internally. That is, I can force you to fixate on something, and I can say, the relevant information is coming up at 2 o'clock or at 6 o'clock, and you can maintain that fixation, but put a gain on the information in the region that I told you about so that you actually detect it more rapidly or discriminate it better, okay? Don't have to have any bodily movements to do that, okay? So that's an internal shifting of spatial direction of attention. But we also know from imaging studies and from single-cell recordings with non-human primates that this heightened attention to one region in the visual field appears to be associated with motor planning regions. And in fact, most contemporary theories of attention, neural theories of attention, have visual spatial attention going through the motor planning regions. And in fact, if I were to have you fixate and tell you to, information is coming at 2 o'clock, but I raise your arm, I actually will distort where you put the gain, okay? So that little reference field is kind of attached to where the body is at the moment. So here's the idea, okay? These very young children are really selectively attending with their whole body. They move the whole body to the object, right? It's a very external form of selective attention, really done outwardly, altering the sensory input. Maybe this is a kind of outward-in developmental system that is in training those attentional networks, which then become a whisper of them in adults in some sense, an internal gesture of what took the whole body, now just takes an unexecuted motor plan.
And then frequently they put it in their mouth.
Okay, I'm actually deaf, and with hearing aids, you've got to project.
And at that age, they frequently put it in their mouth.
not quite this age, a little younger.
They've given up with this thing?
These guys are 16 to 18. Yeah, some of them probably are, but not all of them. But that is still part of this whole system, okay? You bring it in and you bring it up. And I'm sure there's a developmental pathway from that which really dominates in the 6, 8, 9, 12-month period up through this. There's going to be a continuous thing. So actually correct. All right. All right, so this is, in the toddler, this is what I just said. You have the sensory motor system that involves all this stuff and could well be the external origins of the link between attention and motor planning. All right, so now the third data part of this talk, which is the problem of joint attention. So when many theorists of early word learning, and particularly the problem of reference and referential disambiguation, think about the problem, they propose that the solution is in the social context, which, again, there is loads and loads and loads and loads of data for this at the macro level, okay? So they're not just making it up, they've got grounds for saying it, okay? But one thing that people tend to concentrate on, and it's critical because the idea is that you're going to solve the reference problem by building formal, common ground. There doesn't seem to be much of a reference problem here. If everybody's right on the orange, what could my mom be talking about other than the orange? And so the correct inference is what the speaker intends it to be, the correct reference. So a lot of the theories that do this talk about what they call triadic attention, and they presume that eye gaze following is the key. Okay, so the idea for triadic would be the mother looks at the object, the mother looks at where the child's looking, and then names the object. The child looks at the object, looks at where the mother's looking, and says, "Oh, this is the object she meant to look at." Okay, because that's what she's looking at, right? So that's the idea. And it's even been proposed that one of the reasons why this works so well, this goes back to that mirror neuron-y stuff, is that, babies and adults have like bodies, and like minds, so this just allows you to, make that mapping in some wonderful way. Okay? Well, they don't have like bodies, and they don't have like minds, okay? We are not 18-month-olds. Not even at our worst, not even at our best, okay? So they have, this is just one example of this. They have very different views with very different dynamics. And if these are two very different dynamical systems that are operating on very different principles in terms of how you select and pick out an object to attend to, how the way you do that, okay, they both select objects, but the way they do that, if they do it so differently, one recentering the object, in the eye field, the other taking the whole body to scoop it out from everything else. How do they couple? How do these very different dynamic systems couple? And we're going to have, this is actually a deep theoretical problem. You've got different bodies, different minds. How do they do this? Okay, so in the last actual experiment I'll tell you about, we tried to solve this, try to get some new insight into this question by going even more micro than a head camera and doing dual eye tracking. So what we do is we, and this experiment was with 13-month-olds, we fit our little guys with head-mounted eye trackers. So that has a camera that's just like the head camera I showed you, takes a view of the field. But then we have little crosshairs that tell you exactly where the eye is fixating at points in time within that field. And we do that for the mom as well. Okay? So what I'm going to do is show you data from this that looks like this. Okay? This is not head camera data. It's not about what is in view. Okay? This is about fixations. This means a child, not whether it was in view, it was in view, but this is a child who's fixated. Eye gaze directed at the red object. Eye tracker lost a moment. Fixated on the red object. Child fixated on the mother's face, child fixated on the red object. Okay, these are a time series of fixations in time. Okay. This is one mother-child dyad. These aren't averages, this is just the real event in real time. as it happened, okay? Pink is looking at the other person's face. Red, green, and blue are looking at the objects. The first thing you can notice about these data, what's true for this child, is true for all of them, okay? These children do not look at their mother's faces, whereas a mother is looking very regularly at the child's face. These children only rarely look at the mom's face. Okay, not very many pink events up there. So overall, across all the children diets in the sample, parents look at baby's face 22% of the time in these images, in these fixations, and children fixate on the parent's face 6% of the time. Not very often. Parents and children also have very, very different dynamics. If you're a developmental psychologist, this won't be that surprising. Parents are shifting rapidly among the objects, okay? Many more shifts, much briefer durations, and even when they have a long, sort of sustained interest in something like the red object, they're glancing around to other objects in the midst of it. Babies have stickier visual attention, okay? When they're on an object, they don't flit around as much, okay? So they switch less often and their durations are longer. Okay? Now, we can define moments of joint attention, and we made up our own operational definition. So to be a moment of joint attention, it had to be longer than 1.5 seconds on the same object, and we allowed glances to the face as long as you return to that object again. So if I look at the ball, look at your face, look at the ball, that counts as a bout of ball attention. And you could glance at other objects if it was for less than 500 milliseconds. Okay? So I could look at the ball, glance over here at something else, and come back to the ball, and that would still be about a ball. If you define it that way, these would be examples of bouts of joint attention, okay, where looking at so here everybody's looking at the red object, only interspersed with little flits elsewhere are faces, everybody looking at the blue object, everybody looking at the red, the green, the red, blue. If we define joint attention in that way, these parents and children, these very different dynamic systems with very different properties are actually looking at the same object 78% of the time. They are very strongly coupled. Moreover, we can look at switching. You know, if someone leaves looking at the red object and moves to the blue object, how quick does the partner follow? About 54% of the time the child initiates a switch, about 42 or so percent of the time the parent initiates a switch. They don't add up. They shouldn't add up because there's some periods that don't meet the definition. But it doesn't matter who initiates the switch, the other follows very rapidly in less than a second. Okay? So not only are they 78% of the time looking at the same object, they are really a coordinated dynamic system in which they are moving together. Okay? And they're doing it without eye gaze following on the child's part. So, again, this creates a really, I think, a wonderful new theoretical problem that people haven't thought about. Given these very different underlying dynamics, but this very strong coupling, the open question is how do they do it? I don't have a full answer to that, and I was going to tell you, I'm not going to walk you all the way through this. I'm going to come right down to the final slide and just have you take my word for it as to how we did this. I don't have a full answer in terms of how they couple, but our best guess is that hands have a great deal to do with it. Most of the switches on children's part were coupled to, sort of where the parent was touching or where they themselves were touching, the object they were touching. Parents, on the other hand, their switching was orchestrated both by the child's direction of gaze and the child's holding. But for the child, it's really deeply, they're attending to hands and hand movements. All right.
I'm sorry. They're attending to their own hand movements
Yep.
or their mom's hand movements?
Both. Young children are primarily looking at objects in their own hands or objects in their parents' hands. Okay?
But
And
they look at
if
their
their
own
mother,
hands more, you said earlier, right? Than
No.
I thought it was 57 to 40 or something like that, when they're holding, no?
No.
No.
when objects are big in their image, okay, when they are dominating and the only object in view, That happens when the child is holding an object, okay? Okay. So, when it's big in view, they're holding the object. This question was, when do they switch? If I'm looking at this object and switch to that one, what makes me go there? I switch, okay, when my mom is initiates holding a new object. I also switch if my hand hits something else or I'm holding something else. That is, they're looking at what they're holding and they're looking at what parents are holding. Okay. A lot of the time, not 100% of the time, but a lot of the time. And switches seem to be closely related to holding behavior. Who's holding what? Okay. All right. So I want to say what I think the origins of reference is, which is how I began this talk. Given the close dynamic coupling of these two, and as I said, I don't understand the dynamics of this. There's a lot of things that might be making this so tightly coordinated. It's unlikely to be one thing. Okay. But from the baby's point of view, in these kinds of coupled interactions with their parents, 78% of the time what they're looking at is what their mom is looking at. And if moms are naming objects during those moments, they don't have to figure out reference. Reference is like done for them, okay? The object is what's in view. This is what mom is about at this moment. This is what the words are about at this moment, okay? And it's solved by this early dynamic coupling. And from that, we might get our higher level, more abstract ideas about reference and aboutness and whatever. So it works because it is very social and because we're a tightly coupled dynamic system early on. All right, so what have we learned? Toddlers' active engagement with objects creates a highly dynamic one object view at a time. This reduces clutter and visual competition. It stabilizes and sustains visual attention. It supports learning object names, and it may be the developmental origins of the adult attentional network, which doesn't have to be quite so external. Of course, parents are sensory motor systems too, but they're different, okay? They are a different sensory motor system than their children are. Yet, nonetheless, they couple. And I have that question mark there to acknowledge that we don't quite know exactly, haven't quite traced out how that works. All right, so let's go back to the voter. What does this have to do with thinking about things at the macro and the micro level? And about going between levels? Well, I think this is a really complex problem to think about, and I don't have like a direct answer. But when you have new tools that magnify, which really is what these going down to dense multimodal measures are, they're magnification of sort of the higher level things we observe. They allow us to see a structure that was unimaginable and unexpected. You find out things you just literally did not know and could not predict. And some of what you find could be incommensurate. That is not mappable at all to your earlier ideas at the macro level. Now, sometimes they won't be, okay? I mean, sometimes you'll be able to link them. You can sort of see this, you know? That's a blow-up of the fly eye. But this is the point of a needle. I mean, I don't know. I wouldn't have known that structure was there. Right? You can't really infer it before you've been down at the micro level. Now, the thing relevant to the data that I talked about here is that we tried to go micro to look at these kind of phenomena, as I said, that are really well documented, social, so forth, at the macro level. But most of what is being talked about at the macro level hardly seems relevant when you get down to the micro level, or not exactly relevant in the same way. So, you know, neither the assumed input that we're dealing with, nor the findings, these are your typical sort of joint attention contexts, by the way. One object on the table, the person looks at it for a very long time. You know, quite captures what's going on in these more free-flowing dynamic contexts where these guys are moving together, shifting their attention together at a very rapid rate, operating as a single system in time. So, you know, if we have at the macro level things like, triadic inference of the intended referent from looking at the direction of eye gaze, it's unclear how you're going to make that play out in terms of these kind of phenomena. They just don't seem to have anything to do with each other. Which doesn't mean that's wrong. Might mean it's irrelevant. But I think that even though it's not clear how we're going to go from that macro level to the micro level, because the micro level's not just going to be made of little pieces that add up to our macro level constructs in any transparent way, I think we just have to go for it anyway, just like you'd want your researcher in oncology to do it. Even if it's not easy, you just go for it, okay? But it could be that from a developmental perspective, that our mature ideas about reference, our mature, grown-up ideas about reference, at the macro level, and even our ability as adults to rapidly follow gaze direction, really rapidly, just like those kids and their parents are shifting, their attention on objects together, probably not through eye gaze direction. We can follow eye gaze direction very, very rapidly. That, again, may emerge out of this more whole body system. It may actually entrain it and teach it if you take a developmental perspective as to how it might emerge. All right. So the proposal I've got is that we need to try to explicitly map from the macro to micro. We need to know the overlapping and redundant pathways in its full complexity, even if it's, not easy. But we may also have to let some old ideas go, and I actually think we also have to be open-minded. By going micro and trying to bridge levels in this way, it seems highly likely that we are going to find out things we just didn't know. Okay? That you can't have theoretical commitments. All right. So I'm ready to end, and I need to thank my collaborators, particularly Shohei Hadaka and Alfredo Pereira, the two amazing postdocs. And of course, for those of us guys who do all this stuff, we have to thank our money. All right, so I'm ready